Let's start. Hello, Mr. Albert Clark, the United
Hello,
States. Hello, how are you, sir?
it's fine.
Okay, let me complete the introduction because that is something which we always try to present a tribute to you. United States, amazing, retired Air Force Lieutenant Colonel Sir Albert Clark. We have it. So, yes, sir, today what we are discussing for our audience.
We're going to discuss about the new engineers that are engineering our future.
Oh, that's amazing. So please elaborate, shed some light on that.
Okay, well, there's numerous things like my first book I wrote, World War III. It started with EMP.
Mm-hmm.
A lot of military equipment is protected from EMP, like the E-3 AWACS radar plane,
Okay.
which is, and however, the engineers don't understand that. The lieutenants and captains that have never really been in the military. They went directly from training to an office job.
Okay.
So so they don't understand warfare or EMP or things like that. So they that's
Mm-hmm.
an expensive proposition
Mm-hmm.
because like on the uh uh like the Arabs gave Trump a new 747 airplane, but that's a minor cost to buy the airplane. It might be nice, but it to make it a command airplane that has to be protected from EMP, it has to have all the
Okay.
electronics installed in it for communication. We're talking several $1 billion just for one airplane.
Oh my God.
For example, in the E3 AWACS, it was a converted 707 airliner, so it
Okay.
has windows.
Yeah.
Well, gee, those windows would allow in EMP, electronic pulse.
Uh,
Would go right through that glass and right into the airplane.
okay.
Well, so what you do is you yeah, you have a layered glass with metal inside the two layers
Okay.
to stop the electronic emission, and
Mm-hmm.
they cost a lot of money. So after a
Mm-hmm.
while, of course, the glass gets cloudy or whatever, and you need to replace the glass. Or it gets broken, or on the windshield and so forth, you may get a bird strike and crack the glass. So you have to replace the glass with really, really expensive EMP-proof glass.
Okay.
So it's easier to build an airplane with ordinary aircraft glass, which will withstand the temperature and so forth, just like any other airplane. But
Mm-hmm.
there's no EMP protection.
Okay.
We had to argue really bad with the young engineers that didn't want to put that new glass. They
Oh.
wanted to buy just ordinary plain glass and put in there.
Mm-hmm.
And with some older Boeing engineers, as old as I am,
Uh-huh.
uh, and knowledgeable about EMP, we convinced them that because of the radar on the airplane, it puts out emissions like you wouldn't believe. You don't want to stand close to to an AWACS when it's sitting on the ground if the radar is operating because you might get cooked.
Yeah. Okay.
So we convinced them that for the safety of the aircrew, and by the way, the radar is only one emitter. It has radars all over I mean, antennas all over the whole airplane. Uh,
Okay.
they're all putting out different signals and so forth.
And
So
one
we
more thing
convinced,
before I'm sorry to interrupt you. It's a very technical thing. I'm sure you put some light and experience of you. How we are talking about the EMP, like electronic pulse as well, the encryption of that. And what about the satellite electronic pulse integration of that? What are the chances of that and how it is being more protective of it? Please share some light on that. Yes.
well, you really only have, well, there's two times you might get an EMP.
Uh-huh.
One is a solar flare, if it happens to be directed right at where you are on Earth.
Okay.
Uh, you can get a really good dose of EMP, which
Mm-hmm.
wouldn't necessarily kill you, but it would wipe out all your transistors,
Okay.
or a nuclear bomb going off in space.
Oh.
Now, there are EMP things that have short range, 10, 15 feet, 20 feet.
Mm-hmm.
that where they can use that and aim it at a like a
Exactly.
gun at a car and make the car stall. But
Yeah.
that's not the kind of that's not destroying it's
Uh-huh.
transistors. A nuclear bomb going off 300 miles above the Earth will create a cascade of electronics that uh, is not high amperage. So if you're not holding on to a long wire, you won't get hurt. You might feel your hair stand on end, but
Mhm.
we're talking 50,000 volts with very low amperage.
Oh my
Well,
God.
a transistor can't take more than 5 volts at any amperage.
Okay.
So, uh,
So we are talking about massive energy.
yeah, so the windows on the airplane are very critical, and just in case of a solar flare, which is unlikely, but it could
Uh-huh.
happen.
Hmm.
Or if in a war, somebody's liable to set off a nuclear bomb, and uh, all your electronics are gone, and the people inside are debilitated because of the flash. Even we use special paint on the airplane to reflect the flash, so the aluminum won't catch on fire.
Okay.
Uh, anyway,
Hmm.
the young engineers don't understand that, and
Hmm.
they started to build a new AWACS just recently, and they built two, and then they canceled the program. Probably, I questioned whether they had EMP on the airplanes, the new airplanes,
Okay.
and I suspect they didn't have. And maybe somebody listened to me and checked and didn't have EMP protection, so they said, "Ah, well, that's a bad idea."
So how much is the new aircraft is costing? Please share with our audience if they have working on the wrong direction, how do you think that they can fix it or they already fix it? Please share with our audience.
Well, put it this way, we there was a discussion back when I was still working 20 years ago
Mm-hmm.
that they would just put the AWACS on a new airframe,
Mm-hmm.
just as is, just use the same electronics that we've got, the same radar dome, the whole
Mm-hmm.
bit.
Mm-hmm.
And the Japanese bought four airplanes.
Okay.
Those four airplanes cost $2 billion.
Oh my
We're about
God.
we're about the same as a B-2 bomber.
Each costing $2 billion?
Yeah, and they only had five radar stations inside the airplane
Oh my God.
versus we have 20 something.
Please share the model of that plane as well.
Oh, they put it on a Boeing 767,
Boeing
which
767. Okay. Yeah.
yeah, what versus our AWACS is a 707, which has been flying around since the late 50s. Yeah, the AWACS has only been around since the 70s.
Okay.
But
How
hey,
how
that's
do you spell that? Can you spell it out for our audience so
uh,
they can also
yeah,
search airbags?
AWACS, Airborne Warning and Control System.
Okay, can you spell it once again slowly, sir?
Yes. Uh, A for airborne.
Mm-hmm.
It says AWACS, AWACS.
Okay. I got it, sir. Yeah.
So it's also a control system, see, because
Uh-huh.
uh, when if you're near a battlefield and you've got tanks on the ground and airplanes in the air and so
Uh-huh.
forth, it can talk to anybody. It's got
Oh,
communications like you wouldn't believe.
right.
It can they can still talk to the states if they need to. Uh, it's got radios that people haven't even heard of
Oh
that
my
are
God.
on board the airplane,
So it
and
means
there's very good.
it means that if somebody, I'm sorry to interrupt, it means just to get the crispy content for our audience, just for the information, that if let's suppose if Airborne E3, right? That's you were talking about Airborne E3 Sentry.
Yeah.
If yeah, so if that is flying all the way from the skies of Oklahoma, it means they are able to listen every communication and whatever.
Well,
Correct answer.
I'll tell you a joke that the pilots from the AWACS like to do. They will call. they will call an airplane to airplane communication over the radio
Okay.
and say, I understand you have 250 passengers on board and you got 260 meals. Can you pass those 10 meals over to us?
See, so that is something which is for our audience, and that is the perfect thing. Yes.
Right. So,
Yes.
because they can listen in on just about anything,
Yeah.
including including ground communications.
Okay.
Uh, the radar is powerful enough that they can track a sparrow at 300 miles. But you don't
Okay.
want to do that because you would have too many things on the radar. So
Okay.
we have software that'll filter out the things you don't want to see on radar.
Oh, okay.
But
That's very
you
interesting.
because you can't afford to have 50,000 birds on the screen. You'd never be able to see anything. So, but it has the capability to
Mhm.
track a sparrow. Now, if the sparrow had some way to identify that sparrow versus a cruise missile, you would be able to track that sparrow 300 miles away. But
Yeah.
they can tell the difference between a helicopter and a cruise missile.
Oh,
Now you can hide from it by being behind a mountain because radar doesn't pass through mountains very well.
oh,
But
okay.
you're also flying over 30,000 feet, which means you can literally see down most of the canyons and valleys and over the mountains,
Mm-hmm.
mostly.
Oh,
But
okay.
there are dead spots naturally because radar is strictly line of sight. Now
Mm-hmm.
your sight is very long when you're 35,000 feet.
Mm-hmm.
You can see a long ways, but you can't see through a mountain. You can't see through a building.
Oh.
Uh, but you can listen to the radios.
Okay, and please share with our the experience because there is a myth. Since you have experience at the above the level of the ground, 35,000 feet. So please share the secret or the myth with people like we ordinary civilians. We have a myth that there when the uh, hypersonic aircraft is passing above the mountains. So what is the functionality? Does it starts malfunctioning during the flight radar because of the what do you call electromagnetic pulses or radioactivity from the mountains? How do you share that? Please share with us the secret or the myth.
Well,
Yeah.
radioactivity from the mountains isn't going to do anything.
Okay.
We're talking 50,000 volts from an EMP.
Oh my
Uh,
God.
yeah. So a nuclear bomb going off 300 miles above the Earth will it'll cascade down, and one electron bumps into another electron, and it becomes a cascade of electrons coming
Oh my
down thicker
God.
and thicker and thicker. And
Oh
so
my
all of a
God.
sudden, by the time you get down to the ground level, you
Mhm.
got 50,000 volts
Oh my
passing
God.
through. Yeah, just like Tesla could stand there and get and have electricity flying all around him and not get killed by it.
Uh-huh.
Same thing here with EMP. You won't get killed by the EMP either unless you're hanging on to a long wire. If you're hanging on to a half-mile wire, you're
Uh-huh.
going to get too many amps through that
Right.
wire that's collecting
Uh,
all those electrons.
sure.
Matter of fact, um, in 1859, there was a solar flare. We didn't have transistors. We didn't even have electric lights, but we
Okay.
did have telegraph.
Okay.
And it actually burned telegraph wires in two in some places. And in other cases, it
Mm-hmm. Mm-hmm.
put so much electricity into the telegraph office that it set paper on fire
Oh my
with sparks
God.
flying out of the key mechanism
Yeah.
for it.
Very interesting
And we
today.
didn't have
Yeah.
transistors. We didn't even have vacuum tubes. Now,
Okay.
interesting thing about vacuum tubes is vacuum tubes are 1 billion times more resistant to EMP than a transistor because they have an airspace inside. And the airspace inside that vacuum tube will cause the